Now that we've given you an overview of some of the data types that are available in Postgres, let's introduce how to work with some date and time functions. When working with dates and times, it's important to think of moments in time as a sort of hierarchy. Years consist of months, which consist of days, days consist of hours, which consist of minutes, and minutes consist of seconds and milliseconds, and so forth. If we use a simple Postgres function called local timestamp, we can see this illustrated. So we'll say select local timestamp and then run the query. We see years first, followed by months, then days, then hours, minutes, and seconds. When working with databases, we may have countless examples of questions we want to answer using date and time data. For example, which customers rented videos in the month of February? Or how many customers rent videos late at night? Or what's the average number of days between when a video is rented and when it is returned by the customer? Before we try to answer these questions, let's explore some of the different functions we can use in Postgres when working with dates and times. We've already selected local timestamp, so let's go down a row and let's write in another function called current date and see what results. We get today's date formatted as year followed by month followed by day. We can then go down another line and we can use a cast function to cast the local timestamp as date. And we'll alias this as date and then run it, and we get pretty much the same result. We can then put in the local time function in the next line to get the local time at 11:05 a.m. By that same token, I could take that cast function again and say cast local timestamp as time and alias that as time, and I'll get the exact same result, 11:05 a.m. without the time zone. Let's keep going. I will now use current timestamp to see the current time with the time zone added. So this is an interesting difference between the local timestamp and current timestamp functions. You'll see in the current timestamp at the very end there is a -04. This represents the difference between my local time zone and the universal time zone or Greenwich time zone. I can also go down another line and say current_time to get my time, but with that same time zone included. Continuing on, we can actually use current timestamp again, but we can actually specify the specific time zone we want to use. But I specify at time zone in ticks Europe/Helsinki, and I run it again, I can get the current time in the city of Helsinki. If you're curious what other time zones are available out there, you can run a simple query, which I will put down here in a comment block, which says select star from PG_time zone names. If I run this query, I will get a table showing all of the time zones that are available inside of Postgres. For instance, if I'd like to see the current time in Caracas, I can take this value and say current time zone in America's Caracas, run this query again, and I will get the current time in Caracas, Venezuela. So, a great example of some of the flexibility that you can build into your Postgres queries using time zones. We continue going. Let's explore the extract function, which allows you to pull different parts of the date and time hierarchy out of a given date. For example, we'll come down and on new line, we'll begin with extract and then open parenthesis, and we'll say year from current timestamp. Close parenthesis, and we'll refer to this as year. Run the query, and we get the year as 2021. Let's go back and clean up some of our earlier work that we did so that we can allow more space inside of our query tool. Now let's do the same thing. I'm going to copy this, come down, add a comma and a new line, and this time let's say extract month, and then let's come down. Let's alias that as month, and we're going to add a few more lines. We're going to add 3 more lines pasted below. We'll say day, aliased as day, hour, aliased as hour, and then minute, aliased as minute. And then if we run this query, we get the hierarchy of our current date. The year the month, the day, the hour, and the minute, all broken out into separate columns. Another way of doing this is with a function called datePart, which takes a given date and breaks it down into its different parts. So we'll come down a couple lines, start our datePart function, and this just has a slightly different syntax from the extract function. We're going to start with a year inside of 2 single ticks, then comma, and we'll say current date as today's year. Let's take this and copy it 2 more times. We'll say month, current date as today's month. And then we will say day as today's day. Notice how I'm putting double ticks inside of these quotation marks. This is what is known as escaping. If I just had a single tick in here, SQL would try to treat this as me defining a new string that it wants to work with. And if I tried to run this, it would cause a SQL error. So I'm using double ticks inside of these quotation marks to, quote, escape my string and thus make sure that I don't receive any errors when I run this SQL. Now let's take this and run it, and we should get the same results we got a moment ago. datePart is going to return the year, the month, and the day of the current date. Which is better, datePart or extract? Well, they both do the same thing, so I don't think that either one is really better than the other. Next, let's learn a new function called dateTrunc or dateTruncate. This is very similar to the truncate feature that we used earlier in this week, but it's going to truncate the date instead. That's going to be a little bit different, so let's take our 3 lines of datePart and copy them, and then let's paste them below themselves. Then let's replace datePart with dateTrunc on each of these 3 lines, and then we're going to alias these as trunc year, trunc month, and trunc day. Now let's run the query and see what happens. Notice that we're actually getting a full date time column now. Instead of parsing out the individual components of each date, we're actually getting that full date, but they've been truncated in some way. dateTrunc is, first of all, with the year value, going to give us the first day of the year. So it's giving us January 1st, 2021. If we pass it the month argument, dateTrunc is going to return the first day of the current month that we are in. And if we use dateTrunc with the day argument, we will get the day that we are currently on, but the first hour of the day that we're on. This is a little bit confusing, but it illustrates what datePart does as opposed to what dateTrunc does. Why would we use dateTrunc? For instance, if you wanted to dynamically determine the first day of a year or the first day of a month for a given column that you pass in the example you see here, I've selected the rental date from our rental table. In the second line, I've got a dateTrunc function, and then in the third line, I have a datePart function. If I run this, I will get all of our rental dates. But with the dateTrunc function, each date has been truncated to the first day of the month on which the rental occurred. With the datePart function, I've actually got the integer value of that month, the number 5, brought into my third column. The last datetime function I will demonstrate is the age function. We can use age to determine how much time has passed between 2 dates. So, for example, we will say select age, local timestamp, then comma. Then, in order to give it something to compare to, we will give the dateTrunc function, open parentheses, and we'll get the start of the current year that we're in. So we'll type in year, comma, local timestamp, and then close 2 parentheses and say as age example. When we run this, we get a value returned to us that says 4 months, 4 days, 11 hours, and 16 minutes since the start of the year. So these are just some of the ways that you can work with dates and times in Postgres. In the next couple of videos, we'll explore some of this in a little bit more depth.